Hello student, today we are going to study Tollen test and Fehling test. Tollen test gives silver mirror and Fehling test gives red PPT. Tollen test and Fehling test are the very important chemical reaction of aldehyde and ketones. Here aldehyde gives Tollen test and Fehling test, but ketone does not give Tollen test and Fehling test. So to distinguish aldehyde and ketones, this is the very important chemical reaction. In Tollen test, what reagent is used? Tollen test is the ammonical silver nitrate solution. Ammonical silver nitrate solution is called Tollen's reagent, and when AgNO3 reacts with NH4OH, it gives gray PPT Ag2O, and when gray PPT redissolve in ammonium hydroxide, it gives Tollen's reagent. This is the Tollen's reagent, and we use this reagent for the chemical reaction. Here this Tollen's reagent is a diamine silver hydroxide, and Tollen test and Fehling test is oxidizing agent, so it oxidizes aldehyde, and both do not give ketone, so there is no reaction for ketone, and Tollen test itself is reduced. And what is Fehling reagent? Fehling reagent is alkaline solution of copper sulfate containing some Rochelle salt. Rochelle salt is sodium potassium tartarate, and Fehling solution A and Fehling solution B. When we mix Fehling solution A and Fehling solution B, then Fehling's reagent, that is Cu plus 2 and plus OH minus, is formed here, and this is the Fehling solution. And in Fehling solution A there is a copper sulfate, and in Fehling solution B there is a sodium potassium tartarate in alkaline medium. In Fehling solution A there is a copper sulfate solution, whereas in Fehling solution B, Rochelle salt with alkaline solution, which is called sodium potassium tartarate. Here the Tollen's reagent is AgNH3 whole to OH minus. This is the Tollen's reagent, and this is oxidizing agent. So aldehyde oxidize, and this Tollen's reagent itself reduce. This is oxidizing agent, so itself reduce. And in Fehling solution, Fehling reagent is Cu plus 2 plus OH minus. We use this reagent, and this is also oxidizing agent. So aldehyde oxidize, and this Fehling's reagent Fehling reduce. The difference between the Tollen test and Fehling test is Tollen test both aliphatic and aromatic. Aldehyde gives Tollen test, but Fehling test is given only by aliphatic aldehyde. Aromatic aldehyde do not give So to separate the aliphatic aldehyde from aromatic aldehyde, we can use Fehling test. For aldehyde, there is presence of C double bond OH group. For ketone, there is no hydrogen with carbonyl carbon. This carbon containing in both sides there is a alkyl group, but in case of aldehyde, there is a presence of hydrogen with carbonyl carbon. So Tollen test is given by that aldehyde. So for Tollen's reagent, for Tollen test, carbonyl carbon should contain hydrogen. In ketone there is no hydrogen with carbonyl carbon, so it does not give Tollen test, it gives Tollen test. Let us see Tollen's test. Example for aldehyde, second member of aldehyde, CH3 C double bond O H. Acetaldehyde react with Tollen's reagent. Here Tollen's reagent is Ag NH3 whole 2 here plus OH minus. Then in Tollen's reagent, silver mirror is formed. We know that the fixed one is Ag, this silver mirror is formed. And what are other what are the other product formed? Let us see here acetaldehyde, and we know that Tollen's reagent is oxidizing agent. This is oxidizing agent. So this acetaldehyde is oxidized to carboxylic acid. So this acetaldehyde oxidized into acetic acid. What is the molecular formula of acetic acid? CH3COOH. Here addition of oxygen. So what we can write? CH3COOH, but do not write H. Yeah. Here H is removed and CH3CO minus ion is formed. This is the acetate ion. This hydrogen is removed here. And water is formed plus H2O, and here is ammonia. So ammonia is also formed. Here we see that in this Ag, this is the oxidizing agent. This reagent is the oxidizing agent, and in this Ag, silver is in +1 oxidation number because ammonia is in 0 oxidation number, 0 into 2 and total equals to +1. So Ag is in +1 oxidation number. And in silver mirror there is Ag in elementary form, that is oxidation number 0. So Ag +1 to 0, +1 to 0. So Ag is reduce, decrease in positive charge, reduce. A gain of electron reduction. So itself, Tollen's reagent itself reduce. So what is the trick? Addition of oxygen here, one oxygen, and remove this hydrogen, and water will be formed here, H2O, and this NH3 will be formed here, and this Ag is separated and form silver mirror, precipitation, silver mirror, and acetate ion is formed. To balance this chemical reaction, here we can put 2 Ag, and here is also 2. So nitrogen is 2 2s are 4, so here put 4. And for this OH minus, and here is H2O, it is how many plus charge? 2, so you have to put here, and here is -1. So we have to balance the charge in reactant and product side. So in reactant side there should be a 1 negative charge, so there is 2 positive, and if we put 3 here, then there are total overall 1 negative charge and 1 negative charge in product. One question here: distinguish benzaldehyde and acetone. To distinguish benzaldehyde and acetone, we can also use the iodoform test. In iodoform test, acetone gives iodoform test, benzaldehyde do not give iodoform test, because in acetone methyl ketonic group is present and it gives LOPPT, but benzaldehyde there is no presence of CS3 methyl group, so we can use iodoform test also, but we are using here Tollen's test, benzaldehyde and acetone. Tollen test, if we use Fehling test, if we cannot use Fehling test because aromatic aldehyde do not give Fehling test and acetone also do not give Fehling test, so you have to use iodoform test or Tollen's test. Here let us see the chemical reaction. What is the molecular formula of benzaldehyde? Structurally we are writing here benzaldehyde CHO, and Tollen's reagent is AgNH3 whole 2 plus OH minus. Very simple. We have to use if we want a valence, we have to use that same 2 and 3 in this Tollen's test. Here what is the product form? Let us write here benzaldehyde. This is benzaldehyde, and this is Tollen's reagent. This benzaldehyde is oxidized. You know that Tollen's reagent oxidizing agent, benzaldehyde oxidize. Oxidize means addition of oxygen, aldehyde form carboxylic acid. So COOH, benzoic acid is formed, but we do not write benzoic acid, we write in ion form. This is benzoate ion. What is this? Benzoate ion. Oxidize, this oxidize, CS oxidized by a hydrogen removed by plus silver mirror Ag. This is a silver mirror. Tollen's reagent is reduced here, plus water H2O plus ammonia NH3. So what we have to write here? 2 and 3 total charge 1 minus and 2 Ag, and here is nitrogen 4 and 2 water. But acetone does not react with Tollen's test. Here we are writing the Fehling solution, Fehling test. What is the Fehling's reagent we use here? Cu plus 2 plus OH minus. We have to use this reagent as a Fehling's reagent. Aldehyde, let us write the molecular formula. Very simple aldehyde, that is acetaldehyde, CS3 C double bond OH. This is acetaldehyde. When react with Fehling's reagent, Cu plus 2 Fehling solution OH minus. A simple mechanism like Tollen's test, it is oxidized because Fehling solution is oxidizing agent. This acetaldehyde is oxidized into acetic acid. It forms CS3COOH. We do not write H. So this is acetate ion. This is the acetate ion. This is oxidized. Okay, and water will be formed here, H2O, and rate PPT of Cu2O is formed. Here copper has a plus 2 oxidation number, but in this Cu2O, cuprous oxide, copper has plus 1 oxidation number. Here plus 1 oxidation number, so Cu plus 2 to plus 1, change in oxidation, plus 2 to plus 1, loss of gain of electron, so it is reduced and rate PPT is formed. Very simple reaction. But aromatic, we already written, aromatic aldehyde does not give Fehling test. And ketone does not give Fehling test. To balance this chemical reaction, here Cu is 2, so put here 2, and oxygen is added, one oxygen is added here. How many plus charge here? Plus 4, here is plus 4 and minus 1, total plus 3, but in this product side there is minus 1, so to make this plus 4 to minus 1 we have to use here 5 minus and plus 4 minus 1, so 5 OH minus, and how many hydrogen here? 5 6, so you have to put here 3, yes 3, and this is the red PPT. Very simple reaction of Fehling test. Now let us see some example to distinguish. First, benzaldehyde and acetone. Benzaldehyde and acetone. Benzaldehyde gives Tollen's test. It gives Tollen's test, but it does not give Tollen test. Benzaldehyde do not give Fehling test. Acetone also do not give Fehling test. Benzaldehyde do not give iodoform test. It gives iodoform test. Iodoform test. Okay. Yes. Another example: propanol and diethyl ether. In propanol is aldehyde, of course it gives Tollen test, but diethyl ether does not give Tollen's test. Does not give Tollen test, it gives Tollen's test. And Tollen test. We already write the chemical reaction. So very simple mechanism. For all aldehyde you can use same basic term, basic trick for the Tollen test. And another, propanol aldehyde to propanone. This is ketone. It does not give Fehling as well as Tollen test, but it gives it is aliphatic, so it gives Tollen's and Fehling, both T and F. It does not give T and F, both it does not give. Another, in number 4, acetaldehyde and benzaldehyde. Let us write the molecular formula too. Acetaldehyde is CH3 CHO and benzaldehyde is benzene with CHO. It both gives Tollen test, but Fehling solution it given by aliphatic aldehyde and it does not give Fehling test. Does not give Fehling test. And also this aldehyde gives iodoform test. It does not give iodoform test. It gives Fehling test, iodoform test, Tollen test, but it gives only Tollen test. For iodoform test, here CH3 group is present with carbonyl group, and very simple mechanism you can write here. In number 5, acetaldehyde and acetone, we already discussed about it. Formic acid and acetic acid. Formic acid and acetic acid. Let us write the molecular formula as C double bond O OH. It is the formic acid, and acetic acid is CH3 C double bond O OH. In this formic acid there is a presence of this part. This is the aldehydic part, that is a functional group of aldehyde. But in this case there is no any aldehyde functional group. There is C double bond O, but there is no hydrogen. So it gives Tollen's test. It gives Tollen's test. but it does not give Tolen test. You can write the chemical reaction. It is also very simple mechanism. Another distinguish here, number 6, acetic acid and acetaldehyde. Acetic acid and acetaldehyde. In acetic acid does not give Tolen test. Yes, acetaldehyde gives Tolen test. So it does not give Tolen's, it gives Tolen's test. So these are some simple tricks, some idea for the Tolen's reagent and Fehling solution. Thank you for watching this video. Please do like, subscribe and comment for more videos.